estimate based upon this or based upon this, right? So there's a normal probability plot, then the mu and standard deviation can be estimated. Okay. Then, so the sigma, estimate sigma, then CP hat can be estimated, or the sigma can be estimated by the R bar divided by D2. It is another way. Or this is R bar divided by D2 another way. This is another possible way. Twin the twin system. In addition to this, another way to estimate the sigma. What do you think? S bar divided by C4. Yeah, am I correct? This is R bar divided by D2, C bar divided by C4. Do you get it? Jingyi, am I correct? Okay, sure. So this is the way illustrated CP, R bar divided by D2, then sigma can be estimated, upper control limit, lower control limit to get this number. Okay. So then move to move to the page 224. PCR CP in equation 8.4 has a useful particle interpretation, namely the P. We take the reciprocal. So for the hard bake process, 83.89%. .89%. So that is to interpret it as the 83, almost 84% of the specification limit has been used by the process. So the specification limit is 100%. How much has been used? 84%. 84%. Get it? So one-sided PCR, move to. The bottom of the page 324. So upper specification limit, the minus mu divided by 3. So now we consider two-sided. We just cut them in half. One-sided, the upper and lower. The upper consider mu. No, the upper specification limit minus mu divided by 3 sigma. On the contrary, the mu subtract the minus lower control limit. No, lower specification limit divided by 3 standard deviation. So this is US. This is a LS. So this is upper. This is it's called the CPU, the potential capability, the upper potential capability. This is called the lower potential capability. So the interpretation of the PCR on the page 325. This table 8.2, values of the process capability and the associated process fallouts. Fallout means how much of the product being produced going to fall out of the specification limit. So fallout for a normal probability distribution in defective PDN, there's a part per million opportunities. So that is n statistic control, like It's a two-sided PCR 300. Yeah, let me see that potential cavity ratio. This is one-sided. Okay, like this. If it's 1.0, 1.0, PCR equal 1.0. PCR equal to the 1.0. What is that? What does it imply? What does it imply? Okay. What does this number imply? Upper specification, upper spec limit minus lower specification limit. 6 sigma equal 1.0. So that is two sides. 1, 2, 3, 1, 2, 3, and then upper specification limit, lower specification limit. So we consider the process flow out going to be in center, in between, cover 99.73%, right? Then 1.0 right here. So totally 2,700. So this is a point 0.027, right? So it covered 973, so the process flow are going to be the 0.0027. Am I correct? Yeah, then, so turn into the ppm. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Turn into the ppm. Okay. 2700. Okay, then we like to get. If. So look at this number. We expect this number larger better or smaller better? Neil? 你要去罚站了，拉着拉你的头了。Yeah, of course. The larger better or smaller better? 静。This number? This number is larger better, this smaller better. Huh? What? What? Yeah, of course. ppm. We expect it smaller as possible. Okay, then would like to calculate 1.2. If it is 1.2, it reduces. Why? The PCR increases and ppm reduces. Why? How come? Sister, younger sister. 为什么呢？没有，这不是英文哈，抱歉。Yeah, why? Why? Okay, 学习鼓掌。That's your chance. That's your opportunity. That's your time. Why, when we increase the PCR, then the ppm decreases? Why? Okay, Mr. Dodger. Why? 好了，赵小姐。Okay, now don't waste your time. Okay, don't hurt yourself. It's too fast. Okay, gentlemen, it's going to be in the task. Please pay attention to what I said in the following 10 minutes. If the PCR is equal to 1.2, for example, any number can be given in the answer. Then, that's the upper specification limit minus lower specification limit. 6 sigma. Am I correct? Yes. So that is two sides. 1, 2, 3. This is 1, 2, 3. Okay. This is a mu. This is a mu plus the 3 standard deviation. This is a mu minus 3 standard deviation. Now I'm asking, so what is this? If they are center, specification limit centered on the process mean. Then where it should be? Where should be? Where should be the upper? So it is 1.2. So specification limit must be wider than the course limit. Am I correct? So what is the upper specification limit? First of all, we need to determine it should be larger and the lower specification limit should be smaller. And where the location it should be? Where the location it should be? 班长，说话。我说，我讲中文了，我火大了，我告诉你，这1.2懂吧？那代表我的产品界限是不是要比我的公差界限要来得宽？对。它 PCR 才可能带1.0，对不对？对。那请问我的规格上限应该在哪里？来，学长说。我知道啊，现在这个位置应该是什么嘛？我已经告诉你1.2啦。加0.6，3.6是什么？0.6。加0.6。怎么算呢？上面就代表7.2。7.2，6，所以7.2除以2刚好是多少？3.6。就1，这边是3.6。那这边呢？减到123减3.6 ，right？ 3.64。所以说，请问一下，是不是可以算这边的面积？是不是可以算？当然很难算了，这边应该是看一下，这边是来你们查3.6，然后后面去查 check the lookup table on the box。
因为那个 PCR 还没1.6，然后它
还有一个方法，来同学注意一下，这是1.2倍，右边是3倍，它是它的几倍？1.2， 3直接乘以多少？1.2结束。Let me say it again. This is 1.0, right? And on the right hand side, left hand side should be the 1.2 times. So this is 3, and this should be the 1.2, the 3 by 1.2. This is 3.6. Quite straightforward. Okay, 3.6. Where is the probability to the right hand side? Above the 3.6. 那3.6是多少？来，快点，好，快点。哎，你不是有本笔记本，抄得很漂亮，今天没带来，想让你改变心情。
变轻了。
多少？考试一定考的啦，一定考。多少？
那个面积是
0.0多少？0.00多少？119。
单边的。
119，然后再乘2，对不对？0.00238，对吧？然后变成 PPA，12345623800，是不是？来看一下。哎，多少？那增效的，那怎么讲？3180，我是什么地方错了？38。1.2318，159，到底是159吗？到底是多少？那班长你是怎么查？眼睛坏了？快点，到底怎样？班长，到底多少？1.2，多少？0是多少？这个都不会查。 1.2，那这是多少？3.6嘛，对不对？3.60，3.60，单边是0.00，我眼睛不好，几个角？00016，对吧？Y2, this is 0.00038 equal to 123 PBS。班长在搞啥？怎么查啊？
我算到那个3 sigma 到3.6厘。好，
知错了没？
可以理解。
可以吧？Can you get it? Okay, thank you. So then you know how to create this number, this table. Any questions so far? Any questions? Huh? Oh, I'm sorry. Yeah. I'm sorry. 所以说它是多少？差不多了，它318，我们是多少？320，差不多。Yeah, approximate. Okay, then. So far, normally good. Okay, good on Okay, so far. So CP, okay, then this is the problem of the CP. The CP does not take process centering into account. So it is only a measure of potential capability, not actual. This is only potential, not actual. Why? Why? Since the center is not considered, it is really targeted on the center of the specification area. So it's only considered like this. This is really highly potential. This is really capable. This is okay. CP equal 2.0, CPK 2.0. So what is the CPK? CPK is take the minimum of the CPL and the CPU. CPL and CPU. Why? Why we take the minimum? Of course. If the one side is larger than the other side, now we only take the minimum. So at most we can say the actual capability with respect to the minimum value. So take the minimum of. So this is the actual. This is actual capability. Then, like this, CP always equal to 2.0. Why? Even though the center moving around, CP still remain constant. Why? Since the CP does not take the center into consideration. And CPK now, on the contrary, CPK take the centering into consideration. You can see that when the center is off the center of the specification limit, then CPK reduces. The CPK decreases. Then CPK move to that. Originally, even though we have a potential 2.0, CPK still equal to 1.0, since this is one-sided. Look at this. Yeah, look at this. And can you take this one, this example? What is the CPL and the CP mil? For this example. Okay, let's take this example. So, what is the CPL? The CPL lower is a mu, minus lower simplification limit divided by 3 sigma is equal to lower. So this is, let me see, this is 53, right? 53. Minus lower specification limit, 38. Divide by 3 times sigma. Sigma is, let me see, sigma is equal to, 6 divided by 3 is equal to divided by 2. So this is 6. And 13, right? 15. And this is a CPU. This is the upper specification limit. Upper specification limit minus mu divided by 3 sigma. The upper is 62. 62 minus mu is 53 and divided by 6. So this is 9 divided by 6. This is 1.5. So take the minimum 1.5 and 2.5. So the CPK is 1.1. So like this. And then further shifted it more significantly further, and CPK keep reducing. And then CPK, now CPK is equal to 0. Since now the CPK turned to negative. Yeah, so once in a while it is a center. Why it is a center in the, so one of them, the mu and upper and the mu coincide. So this is 0, so CPK turned out to be 0 and turned to negative. So wow, even though it is potentially capable, however, if the center is not taken into account, then the actual capability will not be adequate. Okay, so that's why we determine CPK is a minimum of that, like this. So this is the example. So now we move to the 8.3.3, page 328.你们班我好像在
哪里看过？
不是，我上礼拜我不是把你们的那个圣诞变装秀贴出来，就这个网络反应非常热烈。
下面一片
他们
盛赞。
盛赞就是说，他们说这一班将来会是最有成就的。
那一定，
那
一定
不是你们要 take it for as a compliment， 所以说你们真的要努力，因为大家都很。
老师下面留那些人家工作。
我是觉得就成绩不用太好，成绩一般就可以，不用太好。
就是买了些账号。
不要想东想西的，搞这些东西。Yeah, normality and processing capability ratio. The assumption of normality is critical to the usual interpretation of this ratio. So typically, we wish the data approximately follow the normal distribution. Second, for non-normal data option, transform the non-normal to normal. So take the we call the Boxen. The box transformation. Transform the normal data to normal, extend the usual definition PCR to handle non-normal data. So there's a lot of paper, academic paper and the research work that are focused on the non-normal data, modified definition PCR for general family of distribution called the Johnson's distribution.
For the Johnson distribution. 具体想怎么样？
So, first generation, second, okay, let me move on. A3.5. Hold on. 8.3.5. No, I'd like to, okay, hold on. Before I move on, hold on. No, so I'd like to mention. Hold on. Why it's not in proper order? First generation, okay, just don't worry about that. And the 8.20, why did it jump so fast? I don't skip that. 8.4, why? 8.21. Then hold on. I would like to mention this process. No, I don't like that. Okay, let me mention this before I proceed and follow the slide. Okay, page 329. There's another capability matrix. This is equation 8.10. Called the CP. Why did it skip so fast? CPK and CP6 approaches normality define. No, I don't like that. This is complicated. Okay, just skip that. 8.3.4, more about the process center. So I'd like to mention the equation 8.12, CPM. The CPM. Let me see how so look at the equation 8.12. Let me put it.好，别说话了。It's known as the Takeuchi's capability index, defined as the upper specification limit minus lower specification limit divided by 6 tau. The tau is consider the centering, also consider the variability. Variability simultaneously. So then we assume the center is target. is equal to. So this is the center. We wish the process to be equal to the upper specification limit. Upper specification limit. Lower specification limit. Divided by 2. Actually, it just stands in the middle between the upper spec and the lower spec. Okay, then, so we like to define what is a tau. Okay, let me do this. Tau expected value of the x minus 10. X actually, this is the observation, the t is the target. Then, so which can be the x minus mu plus the mu minus target. Expected value of the observation deviate from the center. Can we do that? Yes, we can. Right? Then this is a plus b squared equal to the a squared plus the b squared plus 2ab. Alright, let's take the reparameterization. So what is the first term? What is the first term? Right on. The x minus mu squared. And take expected value. 来，学长，这是什么？学长 ，first term. What is the first term? Of course, by definition. Then, so this is the constant taken out of that. Now, 学长，这个 term 是什么？学长 ，this is a constant taken out of that expected value x minus mu. X minus mu. Of course. Why? Expected value minus expected value mu. Expected value x and mu minus mu. 0, of course. Then, the last one. So this is mu minus t is constant. So take expectation is still equal to the mu minus t squared. Why? Expected value 2 is equal to what? 2. Constant. Expected value to constant equal to constant. Expected value of HK is equal to what? What is the HK? Hong Kong. No, not Hong Kong. Hello Kitty, right? It's still equal Hello Kitty since it is constant, right? Yeah. So that is equal to the sigma plus the mu minus t squared. So what is this? This is a variability. And this is centering. Is a mu is centered to the target or not? Centering. Also consider the square bias. So, then we take this, and finally we take this. So CP, CPM equal to the upper specification limit minus the lower specification limit divided by sigma plus the mu minus t squared. So this is CPM. So you can say there's a formula So equation 8.13. So when if the mu equal to target, exactly on the target, and then CP, and the CPM is equal to upper specification limit minus lower specification limit divided by sigma is equal to the CP. If they are coincide, if the process center, then the CPM is equal to CP. Then take some representation for the process. I'm sorry, 6, I'm sorry, this is, 2, this is 6, I'm sorry. The 6 is missing, I'm sorry, should be 6, 6 is missing. Yes. And the 6 also missing. 6 sigma squared, yes, and then this is the upper so you can see that, this is the CP, and this is the square root 1 plus. Yeah, it's a quite ugly symbol. We call the sign, right? Equation 8.13, the sign. So if the sign is equal to 0, and CPM reduces to CP. Okay, take a break.
Take a break.